Okay, welcome back, students. So here we are, we're doing question 7 of the department sample paper that came out. It was published in 2020, but it was never actually given to students. It was just a sample. So it's a set of questions. I'm going to have page 23 open just to remind me of different notation, different set symbols if I need it. So I'll put that to the side for now and we start reading the question. So here we have always look at the picture first. I have a Venn diagram, and the target set that they want me to shade in or hatch in is the union of A and B. Okay, so I'm going to go ahead and hatch in the union. Now there's nothing, I said union, but I mightn't have known that word. It didn't say union, it just said this U, and you get that off page 23, union. Okay, completed. Next up we have A. Ooh. What is this symbol here? It is difference or less. A, the difference of A and B intersection C. Let's start off by figuring out where is B intersection C. It's this little piece here. Okay, and we need to remove that from A, so we're having all of A except this bit. Okay, let's shade that in. This bit too, yeah. B without B intersection C, so that bit is missing and that bit is filled in all the way around there. And of course I'll just take out my rubber and clear what I did in the intersection just to make sure there's no confusion. Okay, moving on. P and Q are two other sets. P is a subset of Q. Now if P is entirely inside in Q, subset, I don't know, yes they do, they tell you the symbol for subset, but they don't tell you what it is, except it's kind of in the word itself. It's a set that's sub means below, so it's a set that's in. So basically there's nothing out here, okay, because everything in P has to be in Q, so there's nothing out here in this moon shape here out on the left hand side. Write an X in the region of the Venn diagram below which must contain no elements. Okay, put a tick in the correct box to show which statement must be true. Must the cardinal number of P be less than the cardinal number of Q? Not necessarily, because Q could be empty. Must P be equal, the size of P be equal to the size of Q? Not necessarily. And must, oh, this one doesn't look right either. Must the size of P be larger than Q? Hang on, are we looking for could be right or always right? Which statement must be true? Yeah, here we go, back to this one. So what could have happened here is we could have had nothing out here, in which case P would be equal to Q. The size of P would be equal to the size of Q, and you'd have stuff here just. In other words, P and Q would be the same thing. But that's not necessarily the case, because we can have stuff here. Okay, so it's the first option is the only option that could work, and the explanation is okay, so let's go through exactly what I said. Everything in P must be in Q. All elements in P must be in Q. So P equals Q is allowed, and if Q without P, that's out here, if the cardinality of Q without P is larger than 0, then I think I'll do it in words for you as well in a second, in case you, I'd say, so some of you say, well, I would have never come up with that. If the size of Q without P is larger than 0, then cardinality of P is less than the cardinality of Q. Okay. So, but in a nutshell, P intersection Q and Q without P are only regions where elements can be. Okay, students, we'll leave it at that for this one. As always, I'll see you in the next one.